Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of you. Today we're going to learn on the block diagram in chemical process control. Learning outcome of this week is hopefully by the end of this lesson you'll be able to draw block diagram and understand every each of its symbol and components such as block, branch point, summing point, and etc. So basically, you will learn the concept of block diagrams starting from the process, the measured value, which is represented as the PV. The signal will be sent to the transmitter, and transmitter will send the information, and the controller will make a decision based on the set point. And the decision making by the controller will send to the control valve, and the corrective action will be taken from here. So this is basically the concept. The block diagram with the blue color basically is the concept that you transform from the controller, and then this is in the simulation mode, where this is how you draw a block diagram. So basically, block diagrams are formed by a combination of four basic elements. So four basic elements, which is the arrow that indicate the flow of the signal, and then the summing point, this is the summing point, the branch point, this is the branch point, and also the block that consists the mathematical equations. So basically, the arrow is the general indication of the information of the flow. So it represents process variables or control signal, and each arrowhead indicates the direction of the flow of information. And then we move to the summing point. This is the summing point. The summing points represent the algebraic summation of the input error, which is the error is equals to R set point minus C, which is the measured variable. And then we move to the third component, which is the branch point. This is the branch point. The branch point is the position on an arrow at which the information branches out and goes concurrently to the summing points or blocks. And then the final element of the block diagram, which is the block. Block represent the mathematical operation in transfer function form, such as GS. For example, for the process, the transfer function for the process is GS, which is performed on the input to produce the output. Block diagram, as I mentioned earlier, consists of the rectangular block, which consists of the mathematical equation or the transfer function, and then it has a flow input, and also the flow output. So rectangular block diagram represent the cause and effect relationship between the input and the output of a physical system. So the control element represent any of the system component, such as controller, process, sensor, transmitter, transducer, control valve, metering pump, solenoid valve, and etc. So it can be represent any of the component of the process control loop. And the arrow represent the direction of the flow. For example, for input flow, the direction is into the rectangular box, and output is from the rectangular box to the output. So this is the example of the block diagram. So X is the input, and dx over dt is the output of this transfer function or the mathematical equation that describe the process. let us consider the concept of temperature controller in heat exchanger. So this is the temperature controller of the heat exchanger. The input of the controller is a signal fed by the sensor transmitter combination. So the information from the sensor transmitter will be sent to the controller. The output of the controller is the %CO and sent to the control valve to do the corrective measure. So every each of these represent the process, okay, control element, box. The input and the output is basically describe the control element for every each of the component in control loop. We move to the other component of the block diagram, which is the summing point or the signal operation. So this is the circle box in a diagram, in a block diagram. It represents the signal operation. So it can be, the signal could be positive or negative, and it is placed inside the circle to represent reduction or addition of the respective signal. Alright, for example, this is the input coming from the transmitter, represented by Y, and X is represent the input from the set point. And then to find the error, with regards to the circle blocks, the operation is plus and minus. So in order to find the error, error is equals X is plus minus Y, because this is the negative deduction, X minus Y. So in order to find the error or the output from this signal operation, this is the equation. And then we're gonna look at the takeoff point or branching point. So this is the concept. It indicates the flow of the signal to every edge of the component in process control loop. So what is takeoff point? So basically it is a signal that has been diverted into multiple flow. Alright, it indicates the signal which has similar value to various operator to control element. So for example, this is the branching point or takeoff point of the heat exchanger for the temperature controller in heat exchanger. So the information from the heat exchanger will be sent out to the transmitter, and also the output of the heat exchanger. Let's try to draw a block diagram based on this equation. The output will be the x3, and this is the input that consists of 3 signals. And also we have only 2 elements. The element here is A1 and also A2. And the signal will be x1, x2, and also 5. So we start with the summing junction for this equation. So this is your summing junction. We have 3 signals with 2 control elements. Alright, and the operator for first signal will be the positive. The second one is positive, and the third one is negative. Alright, and then the signal consists of x1, x2, and also 5, and the control element for x1 is A1 and x2 is A2. So we have finished with the input, and the output would be the x3. Alright, this is your output. This is how you draw a block diagram for this type of equation. There are several rules for block diagram algebra. Among that is associative and commutative. So for more info, you may refer to the textbook, Principle and Practice of Automatic Process Control, 3rd edition, page 98. Okay, so for this block diagram, how do we draw this equation? Is first by identify the output and also the input. This is the output and this is your input. So the output here is y s equal to, since there is no semi-junction, the equation will be like this: g1 s is the control element times g2s, second control element of the second block diagram, time the input will be x s. So this is the equation for first block diagram. We move to the second block diagram. Since there is summing junction or summing point here, we need to consider the operator of the summing junction. So the output here is ys and the input is x1s and also the x2s. This is the output signal, sorry, the input signal of this block diagram. So this is how we write down the equation for this block diagram. The output ys is equal to, consider the first input in positive value, so g1s, this is the control element times the input signal, x1s. If you refer to this operator in the summing junction, it equal to minus, so the second input, which is the x2 input signal, is g1s, the control element, times the second input, which is the x2s. So this is how we write down or determine the equation for this block diagram. Now we try to draw the block diagram for this equation. X4 equals to integration of x1 dt plus differential of d 2x1 dt power 2 plus square root of x1. So we have three signal with three control element. Alright, so this is your summing point. We have three signal and three control element. Alright, so here this is the arrow and the output will be the x4. So the first signal is x1 and the control element is integration of the x1. Whereby for second signal x1 and the control element is second order differential, and the third signal, so the third signal and the control element is square. So this is how we draw a block diagram with regards to this following equation. So let's try to determine the equation that relating the input and also the output of this block diagram. Alright, so the output is ys is equals to, this is the summation, the operator for both signal and control element is positive. So for the first one is g1s times xs, and also the second control element, the sign, the operator here is positive g2s times xs. So you may simplify the equation as ys equal to g1s plus g2 s, and the input is x s. So This is the relationship of the C input and output in a feedback loop. So basically, this is the simplified version, the relationship between the E over R, B over R, and also C over R. So this is the most common one, C over R, input and output relationship that will be asked. How to derive this one? Basically, you can follow the sequence of the block diagram, and basically the plus minus operator here, it depends on the input of the summing point. If the summing point is positive, all right, so positive, so the equation for C over R become G over 1 minus GH. Alright, so this is if the operator into the summing point is positive, whereby if the sign or the signal into the summing point is negative, the relationship between the input and output of the block diagram would be G over 1 plus GH. Alright. Okay, then we will learn how to reduce the block diagram, this block diagram, to the canonical form isolating block K in the forward loop, and then we try to calculate the relationship between the C and over the R output and input of this block diagram. Okay, first what you have to do is to apply the transformation of this. So we can combine these two block diagram into one, which is S plus S plus 1. So you will get this equation S divided by S plus 1, and then same goes to the bottom one. You can combine this into 1, which is 0.1 divided by S plus 1, and then you need to apply this transformation. We reduce this, we bring the summing point to here. All right, plus. Okay, do refer to this figure. After that, you can apply the transformation of S, the upper transfer function, and the lower transfer function. So at this point, you need to merge or transform K and also S plus 0.1 divided by S plus 1. So how do we transform this one into this one? Remember the relationship of the feedback loop. So C over R is equals to G1, since this is negative, so it plus GH. Alright, so this is the relationship. So the K represent the G, and also S plus 0.1 is represent H. Alright, so rearrange the equation, you will get this equation. Further reduce transformation, combine these two block diagram, and you will get this canonical form of the relationship between C and also R, and the equation is as stated in this figure. Okay, based on the example, we try to solve this block diagram into the canonical form. Right, the first step would be here. So you need to apply transformation of this one first, which is this is the summing point, and then K equal to S plus 1. This is your output, and then this is your input. Okay. Alright, so you apply this transformation first and bring the summing point here. Okay, so after that you further simplify your this block diagram. So plus minus k s plus 1, this is your c, and this is okay. So this one is s plus 0.1. To further transform this block diagram to the canonical form, this form. Okay, so this is the output and this is your input. So to solve this kind of the block diagram, so flashback the relationship between the output and also the input is equals to G. Since the operator here is negative, so 1 plus GH. G is your upper block diagram and H is your bottom block diagram. So to solve this equation, so let's plug in into the equation. G is K s plus 1 divided by 1 plus your G is K s plus 1, alright, times s plus 0.1. So further simplified, the equation is equals to s plus 1 plus k s plus 0.1 k divided by s plus 1, further simplified, and you will obtain k s plus 1 plus ks plus 0.1 k. Okay. Place this equation into the block diagram. K divided by s plus 1 plus ks plus 0.1. Okay, this is how you change from the more complicated block diagram into the canonical form of the block diagram. So that's all for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh, and see you next week.